Hey class, it's Mr. Woodbury. In this final review video, we're going to go over the two proportion tests. Both the two proportion test and its alternate test, which uses randomization when the conditions are not met. By the way, the conditions we're going to be checking is n times p hat times 1 minus p hat for each sample. So we check two conditions in each problem. Now in this problem, we use p hat rather than p because we don't have a value of p from the null hypothesis. So we're forced to use the sample proportion, p hat. In this problem, we know it's a hypothesis test. We've got a level of significance. We're testing a claim. But the way we know it's a two proportion test is because we're comparing a proportion of one group to a proportion of a second group. Also, we have two samples of the form this many out of that many. The first sample, p hat sub 1, is 9 out of 60. The second one, p hat sub 2, is 14 out of 110. So we're looking for two samples of that form, this many out of that many. Finally, think about the question you would ask to get this data. You would say, do you have at least one tattoo? And the answers are going to be yes or no. Categories. Categories, proportions. Okay, let's check the conditions before we get started here. For the first sample, n sub 1 times p hat sub 1 times 1 minus p hat sub 1 is 60 times. Now, 9 divided by 60 is 0.15. I could use the decimal, but I want to show you how to use the fractions just in case it doesn't work out so cleanly. The fraction for p hat was 9 out of 60. Now, for the second fraction, I'm really looking for the number that don't have at least one tattoo. So that's the 60 minus the 9 that do, and that leaves 51. Now, when I multiply this out, we might get a little worried that we see so many fractions, but we can see right away that two of the 60s are going to divide out, and we're left with 9 times 51 divided by 60. And if you try that on your calculator, you'll see that that equals 7.65. That is not greater than or equal to 10. The conditions fail. We cannot do the two proportion test. We're going to use the randomization test instead. Now, real quickly, if you had used the decimals instead, the sample proportion was 0.15, 9 divided by 60. That makes 1 minus that 0.85. You'd get the same result. But if your result is close and you've used approximate decimals, you can always go back to this fraction approach to get a precise answer. Okay, so I'm going to use the randomization test, but it's similar in a lot of ways. The first thing we have to do in any of the two sample tests from chapter 11 is I have to decide which group is going to be population 1. And a common mistake is to take the first set of information that you have, which here is about male students, and automatically make that population 1. The best thing that you can do is look at the claim. The first group mentioned in the claim should be population 1. Here, that is males. So that is a match. But if you set which group is population 1 by the claim you're testing, it will be easier to set up the sign for H1. The null hypothesis here is P1 equals P2. And for H1, we're also going to compare P1 to P2, but I need to know what sign to put in there. I'm looking for suggestions that the proportion of males is higher than the females or lower, but I'm not told either of those. So I'm going to have to go with not equal to. When the null hypothesis is that they're the same, the alternate hypothesis is that they're different, not equal to. Also, watch out, when H1 involves not equal to, our conclusion has to be about those two things being different from each other. The level of significance is given in the problem as 0.05. And because this test failed the conditions, this is the two proportion randomization test. So we're going to go into StatCrunch. What we need to know are these two sample proportions so that StatCrunch can build the randomization tool and we can actually compute a p-value. One other thing about this problem is that when I do it and you try this at home and your friend tries it over there, we're all going to get different answers, but they should be close to each other. All right, let's go over how to do that. This is under applets, resampling, randomization test for two proportions. We're going to select from summary at the bottom half of this screen. Sample 1 was the males. That was 9 out of 60. And for the label, I'm just going to put M. That part doesn't really matter. For sample 2, for females, that was 14 out of 110. F for that label for female. Press compute. And it builds this applet for us that will do the randomization. We're going to go ahead and run that 10,000 times. So click on 1,000 times, 10 different times. The top row lists the p-value if H1 was less than, below. The second row lists the p-value if H1 was greater than, above. But the third row lists the p-value for the two-tail test, not equal to, and that's what we had here. I have a p-value, which is pretty large, of 0.8113. So back to the problem. The p-value that I got was 0.8113. Yours is going to be slightly different, but it should be in that 0.8 ballpark. And when we compare it to 0.05, it's going to be clear the decision that we're going to make. Here we're going to fail to reject HO. That p-value is too large. And that means that there is not, okay, if you're getting tired of writing sufficient evidence to support, I'm going to allow you to write this abbreviation, SETS, sufficient evidence to support that whatever H1 says, and here is that the proportion for males is different. Remember, that's that not equal to part again, than the proportion for females. Not sure if you saw that warning. I'm down to 10%, so we should go through the next one pretty quickly. Let's move to the next problem. We have a claim about two population proportions not being equal. We have one set of sample information for people getting off a plane and another for people about to get on a plane. So we have two sets of this many out of that many. The question we would have asked all of those people, are you afraid of flying? The answers are either going to be yes or no. Categories, proportions. Here, listing population 1, there's not a population that's mentioned in the claim itself. So I'm just going to go with the first group of people that we have the data for. So I'm going to let population 1 be the people who got off the plane. The null hypothesis, P1 equals P2. Again, that's always the case for a two proportion test. H1, I compare P1 to P2. Any suggestion that one's higher or lower? No, we're just testing that they're not equal. So the right sign there is not equal to. I haven't checked the conditions yet. The level of significance was 0.05. For the conditions for sample 1, we would multiply 300 by 81 over 300 by 219 over 300, and we would get 59.13, definitely big enough. If you repeat this for sample 2, we're talking about 200 times 32 out of 200 times 168 out of 200. That is equal to 26.88. Both are large enough. This is a two proportion test. In a moment, we're going to get into StatCrunch and we're going to compute a test statistic Z and a p-value. Then we will make a decision about HO, whether we reject or fail to reject. And then finally, there either is or is not going to be sufficient evidence to support that what H1 says. And here is that the proportions are not equal to each other. All right, let's go to StatCrunch and run through this. Again, I need to know these two samples, 81 out of 300, 32 out of 200. Clean up from the last problem. This is under stat, proportion stats, to sample with summary. For the people getting off of the plane, 81 out of 300. For the people getting on the plane, 32 out of 200. In the null hypothesis, we always leave this as equal to 0. P1 minus P2 equals 0 is really the same as saying that P1 equals P2. If we wanted to show that the first one was 5 more than the second one, we could put P1 minus P2. I'm sorry, 5% more. We could put P1 minus P2 equals 0.05. But we don't do that in this course. For HA, the right sign is already there. We're ready to go. Press compute. The Z-stat is 2.88 with a p-value of 0.004. So Z equals 2.88, p-value 0.004. That is smaller than the level of significance. So that means that we reject HO. This is our way of saying that we believe the null hypothesis is false, and therefore the alternate hypothesis is true. That means that there is sufficient evidence to support that the two proportions are not equal. Okay, in the next video in this series, we'll take a look at the paired difference test, also from chapter 11. We'll see you then.